Hello everyone, in this video I'm going to share some of my experiences in OpenFOAM and AI together and let you know how AI can help us to find a good solution to some of our problems and how AI can help us to know the physics behind some of the tools that it has. And at the same time, I will teach you a trick which is called banana trick in OpenFOAM, and it can be very useful to find a good solution to some of our problems. Just watch the video until the end and you will understand and learn a lot by watching this single video. Okay, let's go to tutorials folder, fluid, then cavity, which is the simplest case study, and we use it for all the tutorials. Go to this folder. Let's first run this without any modification or changes. Okay, black mesh, then foam run. That's it. It runs successfully without any errors. But what we want to do is that if we want to change the boundary condition to something we want a boundary condition like inlet mass flow rate. What we do is, for example, for the moving wall, the type is fixed value, it is recognized, but we don't know what we can use for the inlet. What we can do is just use the banana trick. Banana trick is just to write a random type for a boundary condition or anything that you want to implement, and then run your case for run, and you get an error that they didn't know the type that we have written in the zero folder, unknown patch field. And then it gives all the options that we have to that boundary to put in the boundary condition for the velocity field. If you find your boundary condition here, or if you are not very familiar with the boundary conditions, you can copy this and go to the ChatGPT. Here I will write, give me the best boundary condition for inlet mass flow. And let's see what are the answers. Yeah, we can have a fixed value which was previously used, but the m dot, if you know the m dot mass flow rate, you can use the mass flow rate inlet velocity. But is it final thing that we have to do, or what else? Paste, Control S to save it, then run it again. Now the type is okay, but we should do something else. That please supply mean velocity, volumetric flow rate, or mass flow rate, and rho, which is density. Then we have to either implement the mean velocity, volumetric flow rate, or mass flow rate. For example, if you go with the mass flow rate, it doesn't matter which one, the one that you know the answer, or at least you know the boundary condition. Like if I use 1, run it, it's run successfully, but we get an error because the number we supplied was not great. We can use smaller mass flow rate and run it again. Now everything is fine. We implemented our boundary condition with the help of the AI, or you could do it by yourself, but everything is now fine and working successfully. But there's another very useful command in Linux and OpenFOAM that can help us to find some solutions to our problems. Think like you want to do you want to implement a dynamic mesh in one of the solvers that you want to do, but you don't know anything about the dynamic mesh in OpenFOAM. but you want to know but you want some tutorials or something to start with. How we can do it? One of the ways is to just go to tutorials and find for example, find your solver that you want to do and try to find a tutorial that they use it, but you don't know where is it, where you can find it. So what we do is we use a very useful command called grep-r. Then in this quotation, you can whatever you write, the Linux tries to find that in all the folders that you are. So we are now in the quality folder, but we should go to the tutorial folder. And tutorials. Then we want to know to find some tutorials that they use dynamic mesh. Let's see if dynamic. Wait, and Linux tries to find all the folders, files that they have dynamic word in their file. These are thermodynamics, but yeah, thermodynamic that is not very useful for us. Dynamic mesh type. Where is it? Multi-region, CHD. Okay. Tutorials. We go to the multi-region, CHD. This folder. Engine valve. Then we go to the constant, exhaust valve, and dynamic mesh. This is one of the files that you can use to dynamic mesh, but maybe it's not the case that you want. Then you can try some other folders like or try some other keywords. Or we can go to the solver or tutorials that we are interested, like CD fluid, probably. Then grep-r dynamic mesh, maybe it's a better word. They only have one dynamic mesh ticked, so probably it's not the best folder to do it. We can go to the compressible, warm fluid, probably. LS. Okay. Then try again. Dynamic mesh did. We have ball valve. So we found one of the dynamic mesh there. Then we go to the compressible volume of fluid, ball valve, constant, and dynamic mesh did. And you will find another tutorial and case study that they are using the dynamic mesh. And here again, this is the folder and file that you need for the dynamic mesh. So you will have understand where is the dynamic mesh, which folder is it, how we can implement it. If you want to try other dynamic mesh, which is different from this one, you can use the trick that I taught you previously, the banana trick. You can write again some random type here, then the Linux will give you some good other types that you can use instead of motion solver, and at the end you can find your best dynamic mesh type. If you have any other question, please write it in the comments. I try to answer them as soon as possible, and see you in the next video, which I will teach you how to use AI to understand the physics behind OpenFOAM better.